So, hello to you all and welcome to Etteplan Additive Manufacturing webinars. Before we get started, we briefly introduce ourselves. Ika, would you like to start?
Sure. So, hello everyone. My name is Ika Rytkönen and I work as an additive manufacturing specialist here in Etteplan. I have a background in mechanical engineering that I used to do before, but since joining Etteplan, I've been focusing pretty much full time to additive manufacturing from the beginning. And I've been having this strong interest towards 3D printing and additive manufacturing for quite a long time, for many years, and it all started with getting my own 3D printer at home, and it's been a fun ride so far.
And my name is Tero Hämeenoo. I'm the Department Manager of Additive Manufacturing at Etteplan. I have been in engineering business more than 16 years and now the latest years heavily in additive manufacturing. But briefly about our company. So Etteplan is an engineering service company, over 3,500 engineers and 3 service areas, which are engineering solutions, software and embedded solutions, and technical documentation services. But our additive manufacturing journey has been quite nice. Over the years, we have gathered a lot of knowledge from this new technology, and I'm pleased to host a set of webinars with my additive manufacturing experts. This first webinar starts from the really basics, how to find suitable AM applications. And then our 4 webinar set mimics the AM journey. So we will start from where to find the applications, then we will carry on to the design phase, and from there on we will hop into the cost of printing and industrialization of additive manufacturing production. And I also want to give thanks to the co-organizer Tampere Fairs that has helped us to share this message of these webinars. Originally, we were meant to speak about these topics at the fairs at Tampere at March, but since these extreme times and coronavirus, we are pleased to be able to share our message via these webinars. But Ika, please go ahead.
Thank you, Tero. And once again, welcome everyone to listening this presentation about how to find suitable AM applications. If you have any questions during this presentation or after it, there is a button or a section on the right hand side in the control panel saying questions, and you can type yours in there and then we will answer those in the end of this session. But if we get on with the presentation, I'm sure many of the people who have been following the field of 3D printing or additive manufacturing in industrial scale is quite familiar with many of the cases from the aerospace industry. And those of you who are not, this object that you can see here is actually a fuel nozzle that goes into a LEAP engine produced by GE. And in one engine, you actually have 19 of these fuel nozzles installed. And with this new design they have created, they have been able to create this to be 25% lighter than the original version. It has better fuel efficiency, and it's 5 times more durable than the one being produced in the traditional way. And actually, at the moment, GE has 14,000 engine orders that has come in to purchase these new LEAP engines. And regarding the awesome facts that are within this new fuel nozzle design, despite the ones I already mentioned, it has 20 parts that has been combined into one. And actually, all of those parts are located in the area of the tip of the nozzle on the very, very top. So it's quite remarkable. And it's quite natural that we see many of the aerospace and automotive industry examples in the field of additive manufacturing because they are the early adapters of this technology due to the fact that it's easier to produce lightweight components with additive. So that brings up the question, what can you do with 3D printing in terms of traditional industry, and how can you sort of draw the line from those aerospace components into the ones in your own products? So that's what we are focusing today. And we will start off with a bit of why should you be interested in additive manufacturing, or why should you use it? The first one here on this list is the manufacturing cost, because cost is something that everyone is interested about. It's the first question that everyone asks: how much does it cost, and so on. So there is a possibility when you find out a case that makes sense that you actually do make some cost savings when producing components with 3D printing. And we will go through a few examples today as well. Then making something possible, because with additive, when we produce components layer by layer, it enables us to create something totally different. So, for example, we've had a customer case that the customer tried to do in a conventional way, but just couldn't get it done in a proper way. There were always some problems with the tolerances or the dimensions in the final part that they produced, that they just couldn't get it into working. But when redesigned to use additive manufacturing, they actually could make it done. So that is actually a huge advantage if you think about it. So something you couldn't be doing before, but now you can, and you can get it into the markets. Improved performance is a great example. We already saw the LEAP engine nozzle or the fuel nozzle just a minute ago. But for example, if you think any other nozzles, or for example, hydraulic blocks. So things involving, for example, flow. Currently, if you think about how hydraulic blocks are being manufactured, is that you drill a hole, then you drill another hole, and usually they are in 90-degree angle to each other. And when you imagine the hydraulic fluid going inside those channels, you get a lot of pressure loss in that 90-degree angle. But with additive manufacturing, you can create those hydraulic blocks in a way that you have smooth channels that has nice curves, and it complements the flow. So you get more efficient flow, and therefore less energy is needed in the system itself. Logistics and spare parts is a great area of interest to additive. So, for example, in these times of the coronavirus, in some areas there can be problems in getting components, for example, even or especially if they are shipped from the other side of the world, like from Asia, for example. So with additive, they can be produced more locally, and they can be easily or more easily available. They can be made to order and to the need, and you don't need to store a lot of them in the warehouse. You can just create them when you need them. And overall, the cost savings, once again, I need to talk to you about the cost savings, because it's not always just about the savings that you get in regards to how much does it cost to produce the component. But if you think about, for example, the assembly work, then you have a lot of changes in that as well. So if you can make your component in a way that it's much more easier to assemble, or it has fewer components, then the time speeds up on the assembly line and it becomes more productive. Then customization. If you think about two different components and you want to customize them for different customers, for example, it can be as simple as a logo, or for example, a code for your component, or it can be a different surface pattern, for example. In 3D printing, it doesn't differ too much cost-wise if the components are similar elsewhere. So you can customize your products. And for example, when thinking about hearing aids, about 99% of all the hearing aids around the world are 3D printed nowadays. And the list goes on, and there are quite many examples that is a good way to utilize AM. But overall, it comes down to the added value. So you want to achieve something extra when using 3D printing. There's no point of using it for something that is optimized for, let's say, sheet metal forming. Then it's really hard to compete cost-wise. But I have prepared a list for you guys. But before that, keep in mind that everything is case dependent. So it's a great way to check out online, see different kind of examples to sort of get the food to your brain, what can be done, and therefore inspire you in your own work. But remember that everything is case dependent. So even though something works for someone else, it might be a different case for you. So remember to check it on your own terms before moving too far ahead. But then onto the list. I have 10 points here that I have collected to have sort of a rule of thumb, so to say, to help you in finding out those components. So number one, when talking about components, you don't necessarily need to be redesigning them at this stage. So demand of the part. Is there difficulties to forecast the volume of your components, or is it fluctuating? So do you have, for example, 5 components this year that you need and maybe 500 next year? So there's quite a big of a gap. How much should you keep them in storage? So 3D printing could bring some aid to that by just producing the components the need that you have. Then the increased price of the part, especially with components that have been there for quite a while. So for example, 20 years or something like that. So if the price of the component has increased by a factor of 2 or even more, then that should be one of those ringing bells to start looking at it from a different angle, and perhaps 3D printing could produce a good option on that. Then the euros per kilo. So how much do you pay for the component per kilo? I think in everyone's ERP systems there should be a column for the price and a column for the weight. So if it's something like 1,000 euros or 1,500 euros per kilo or even more, then the chances are quite close that additive can be a great production solution for that. So as I said, these have been all so far tips and hints in cases where you don't want to do too much of a redesigning, but eventually you want to do at least something because that has an effect to the cost. And here is one example from our customer case that we've done. So tip number 4, if most of the material is being removed in the current manufacturing process, then additive can be a great option. So over here on the left in the picture we have a machine component, and about 80 to 90% of the material is machined away. So when thinking about subtractive or material removing technologies like machining, it doesn't sound like it makes much sense to do it that way. So in additive we only put material where it is needed, and therefore by 3D printing it and making these small redesigns, so we follow the rules of thumbs, like for example 45-degree overhang rule, so we try to avoid any possible support structures, can make the process more cost effective. And for example, in this case, we have reduce the volume by 30% because less material means less cost. And there's even potential for more if we would do something like topology optimization. But in this case, the goal was to spend as little time as possible on the drawing board. And with just these small changes, a price reduction of 15% has been done for these components. Then if the annual volume of production is low, then 3D printing produces a nice way to make your components. So when you have small volumes, the cost per unit is quite difficult to affect. It's quite straightforward. If you give an order to a subcontractor with million components, they might be more eager to lower the price per one, but if you only order 10, then they couldn't care much. But of course, annual volume, talking about low volumes, it is quite case dependent. So for example, on the left-hand side here, we have an annual volume of 1,000 pieces. And this is a Y connector for a robotic sander. And here you can see the machine version that was received from the customer, machine from aluminum. And then we redesigned it for 3D printing. And by this redesign, we were able to get the costs down by 40%. We were able to get a better surface finish to it. And because it's application to the end of the robot, we also were able to reduce the weight by 50%, which is quite good in these applications. And yeah, like said, low volumes, very case dependent. To something like a car manufacturer, 1,000 pieces is nothing, but for some smaller companies, it could be quite many. But here on the right-hand side, we can see another example of a mounting tool we did for a cylinder head valve springs. So these tools, only one piece is being made. And when comparing to the machined version, it has better strength and it's also cheaper to manufacture. So the previous version that was designed to be machined and welded couldn't handle the forces in a long-term basis in its end-use application. So with additive manufacturing and those nice curves and bionic shapes, we were able to create a better performing component. Then if you think about the assembly line and you create complex products and you put many components into one and you never take them apart, then why do you do it that way? Well, simply because it's the only way of achieving the final product, or that's how it used to be. But nowadays, with 3D printing, like in this case that Optisus has done, they have combined 100 components into one, and they have reduced the lead time of the design and manufacturing of the component from 11 to 2 months, which is quite much. And overall, they have received even 20% in production costs, or minus 20% from the production costs. And if you think about those 100 components and some guys putting them together in the assembly line, it's quite nice that you can just receive the whole package readily made from the machine. Another example from the assemblies is that if you have such a complex geometry, like for example here, 8 sheet metal components, this has been completely redesigned and now it's only one part, which is lighter, but also stronger in the end application. We already talked a bit about the lead times that it takes to manufacture the components, and Siemens Turbo Machinery has a great case from Sweden. So Siemens produces turbines that are being used for production of energy, and they have these burners inside them. And every once in a while you need to replace a burner because it wears out. So in that repair process, previously they were milling about 60 to 70 millimeters away from the tip. Then you will reattach some new components into it. You weld them together. You need some sanding or grinding in between and all that. And the whole process took them 44 weeks to accomplish. But since finding out the possibilities of 3D printing, they actually now mill only 20 millimeters away from the tip. They put the whole burner inside the 3D printing machine, and then they print that 20 millimeters over there. And this way they have been able to get the service time to 4 weeks, which is quite nice and also brings extra value to the end customer. Then when thinking about injection molded components, especially if they are quite small, in that case quantities can be even a bit higher. So it might be viable to use actually 3D printing to produce them. So in this case that you can see here, Oracle 3D printed with carbon 3D technology 10,000 of these board alignment brackets made in plastic in just a few days, which is quite remarkable. And anyone who knows about injection molding, so traditional methods would have taken months to produce even these molds from steel by milling, and the cost would have been more than using additive. And as a final tip, it doesn't always need to be an end-use component that you 3D print. Of course, prototyping has been there for ages to speed up the production or product development, but also 3D printed tooling is quite a nice option. So as you can see here on the left, you have this quite difficult shape that you need to put in a vise between the jaws. So a custom-made tooling has been created to keep that in place. And these are the bits and pieces that you can basically print overnight. So you can get them on the next day at the work site. You don't need to order them anymore from outside, being machined from a block of plastic, for example. Or on the right hand side, you can see this carbon fiber reinforced welding jig. It can take a bit of heat, so it doesn't matter if there's a bit of welding ongoing, and therefore you can create these custom made jigs that can fit in your production perfectly. So now that we have seen some examples, it's pretty awesome to see those different kind of components that have been made and all that. But the question is, how do you actually design those? How do you do it? To that, I have come up with a little path for you guys. So first step would be to attend our webinars. So for example, next week we have Erin Komi talking about simulation-driven design. And then we have, for example, the costs that are in the business of 3D printing. How can you estimate them, and is there anything you can do about it, and so on onwards to the industrialized additive manufacturing. Then I would say that learn how to design for additive manufacturing. Check those examples from online, learn how to do it, or you can ask from us as well. However, but most important thing is to just get your hands into it and start doing. This is the key step. So you don't achieve anything if you just stay put and do nothing, only observe. But get your hands dirty, start doing, start experimenting, and that's how you can actually get those vital lessons learned or good applications. Your eyes start to open. So get on with it. And I know from a personal experience that attending these webinars can be quite exciting, and you're pumped up with the new knowledge, but then all the hassle and all that comes in the working life and you don't actually have time to do it. So we want to help you. So for you attendees only, if you send a part of your choice that you have been thinking, would it be good for AM? Could this be something that we should be doing? We will analyze the feasibility of using AM in it for free for you. So you can send it to my email address over here. I'll give you just a couple of more seconds to write it down or take a screen capture or however you want. So send me an email and I'll have a look at it. But now I think it's time to have a look at the questions. Here's also a bit more comprehensive list of the hints and tips for spotting AM parts. I showed you a few of them, but there's a bit more.
Good, and thank you, Iikka, for the good presentation. And I think that now it's time for the questions. So let's see. Is Etteplan offering any services to help find parts components that would be a good business cases for additive manufacturing? And the answer is yes. We are doing this constantly to our customers. We have generated different kind of screening models from the part level into a level where we can screen the whole product or assembly and give our indications in a high level, or also make a business case for additive manufacturing for our customers. So like Iikka mentioned, if you have any ideas where you could utilize additive manufacturing, please contact us.
Then I can see at least, does Etteplan provide functional driven design solutions for lightweighting end part with more stiffness? Certainly we do. So we are very much driven as a design house that we do design projects. So if you have something particular in mind, so we can set up a meeting and start working on it. And we have a quite diverse team working on these cases. So we have our AM experts, then we have our engineering analysis experts as well that we can utilize in the projects. For example, CFD analysts or FEA analysts. And on top of that, we have a huge pool of traditional engineering and we can combine that expertise in these projects.
Yeah. Then we have, where can I get more knowledge of design for AM except the examples we mentioned? Well, from the coming webinars, we are sharing cases from Etteplan website. You can find good cases, and well, web is full of good examples how to utilize additive manufacturing. But Erinkomi's next week webinar will focus more about design perspective of AM.
And I can see that summarizing the benefits of AM regarding environmental thinking. So less waste for sure. Then if we start moving from this global manufacturing towards local manufacturing, then so that we have these manufacturing hubs closer to the end use, then of course we will be reducing to some extent the transportation and all that. Of course, it's not so black and white because we still need to be transporting the raw material for that, and there's some debate, is AM green technology or not. So it's a difficult question. To some extent it is, but there is so many things that are moving and that need to be found out so that we can define, for example, for some component, that is it actually greener to do it this way than with conventional way. But yeah, there is definitely a possibility for that.
Then we have a question of the cost, and is it hard to estimate the metal cost of metal parts, any advice how to estimate the printing cost. So it's doable. Well, many service providers provide tools for that one. Basically, you need to, because if it's a layer by layer manufacturing technology, so if you really want to get into an exact price, you need to have the final 3D model ready and split it as layers and then calculate the lasering time and machine costs. But for that one, Etteplan has developed tools where without the 3D model, only with the volumes and complexities and stuff like that, we can estimate the metal printing costs. And in the later presentations, we will also promote and show how we are doing that kind of cost evaluations.
I think that's pretty much all the questions we had so far. So if you have any more questions in your mind, you can always approach, for example, me in this email address that I'm showing once again. And do find the suitable parts and let's check it out if it's a good case for you to start your AM journey with. But at least on my part, thank you for participating this webinar. Tero, do you have something else to say?
No, I also would like to thank all of the attendees, and hopefully you will join us for the next webinars. Thank you, everybody.